of all, I would like to welcome everyone to the System Skill and Low-Level Programming class. I would call this kind of like a gateway class to many of the cool computer system, computer hardware, and computer network topics, as well as things like compiler, how the program actually work, right? So from this class on and anything that required this class as a prerequisite, we'll start to dive deeper and deeper into like what's a computer and how do you actually uh, 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 figure out how it operates and how does it run your program, right? And today we'll talk about introduction to this class. So I would first begin with a course overview, right? Quickly introduce myself for those who never take a class with me before, and especially for this class, it's like kind of like an intro class. My name is Rashada. I'm actually not a professor at MUIC. I got a Thai government scholarship, and my contract basically put me at this place called Thai German Graduate Study at KMUTNB, King Mongkut University of Technology, North Bangkok, the one uh, close to Paramjet Bridge. And it's kind of like almost next to Nonthaburi. Basically, kind of like a little bit like 1 kilometer north, you're in Nonthaburi. My main expertise is computer architecture. What is that, right? So you may be wondering, what the heck do I do, right? Computer architecture basically computer. I basically my thesis is on how to make a better GPU, right? How to go even beyond the limit of what NVIDIA has right now. And now going into things that NVIDIA research and AMD research, Intel labs, like people who are actually inventing new type of hardware for us, for you guys as the user of the hardware, which is programmers, developers, right? How do we keep up with the software? How do we keep up by building cool new hardware? How many of you own an iPhone or an Android phone? Anyone here not owning a phone or smartphone? Hello, right? We all have a really powerful phone, right? This, um, and to be honest, this is like a really combination of many computer architecture, computer hardware, and circuits improvement in order to fit so many things on your phone so that you can enjoy using many apps on a phone right now. Um, And this class, to be honest, is basically one of the prerequisite for one of the system class and also computer architecture class, right? Which is basically how do we design a computer. I can tell that I'm probably the only one, if not a few people in the country who work on this topic actively and still publish research paper over there in the area, right? If anyone here would like to do internships or work with me, am I back? Am I back? Am I back? Am I back? Uh, okay, awesome. It's just my wireless, I think. Let me double check. Ah, it makes sense. Awesome. I'm not even sure where I left off, but basically I'm doing this thing called computer architecture, and we design we design hardware components, right? And I'm one of the only few people who's still doing research in Thailand on this topic. And if you are interested doing internship in our lab, let me know. Aside from that, let's go back to the class, right? You guys are lively. I love it. Office hour right now by appointment. I kind of need to figure out my schedule a little bit. As I said, I have a newborn right now, so my schedule is really a hectic schedule at the moment. Will be on Discord. Sorry about the typo. That's another thing that might happen on my slide quite a bit. Typo. Does not require a textbook. No, you don't need DSOOP, and I'm trying to take into feedback from previous semester, so our assignment should be less reliant on DSOOP. Is that fair? All right, and my cat say hi. She was climbing here, so hi cat. Good distraction. So there's no required textbook. The recording of the lecture, including this recording of my cat, will be on YouTube. Um, and we have the course website. I already posted the rely less on what? Actually, I forgot. What did I say? I basically said there's no textbook. Oh, we will rely less on DSOP. Basically, you don't need to be actually taking the SOP class right now to understand or do some of the labs. That and I'll focus more on using C because that's one of the one of the problem we found, and it is recommended if you have the SOP background, if you took the SOP right now, it can help for some of the things we ask you to implement. But everything that's required for the lab will be explained in the class, right? So if you took the SOP, some of the things we use, like a linked list, basically how do you build a list? A list that you use in Python. How do you implement a list in C? If you know the SOP, it does help a little bit, right? Um, but it's not required. We have a course website. I put in the info for the link on Discord and Sky, Sky Plus, new version of Sky, which actually does perform much better. Anyone like the new one compared to the old one? I like it a lot more. Um, oh, you missed the old one. Why? Oh, it had a queuing system. You should feedback to the department. I think the queuing system can be a good thing to implement, to be honest. Um, yeah, and I really love distraction. It's awesome. I also love like to go sidetrack too. So if I'm going to way to sidetrack, let me know. That's like my thing. My lectures, I go sidetrack all the time. And you guys are good at putting me there. So yeah, please sign up now for the class website. This will be the main source of our communication, right? If your friends were not in this meeting, please let them know this is the link for the lecture. If you have friends who haven't signed up for the class website, please do so now. And I have a quick class survey. I sure, well, you know Python, right? There's a requirement. How many of you are basically took the Python class and still not comfortable with Python? Please raise your hand. It's okay. It's okay to admit that, right? We are learning another language. So it's a good chance to catch up because the reason I think about like not being familiar with Python is just you're not used to programming. Because you're just beginning your career in computer science and your awesome career on being a programmer, right? Um, yeah, if it's two terms ago, you should still remember some of those, hopefully. But the way we think in terms of getting the task done for the program, it gets some use to for the first year. So I can assure you, right, that you get more used to it. And because you're learning a new language, but the way it's structured is still like running line by line by line, have a function call similar to Python, right? So hopefully it is a good practice on programming. You don't need to know, I don't want to say that. You need to know Python. Sorry. Um, Actually, I do like both, right? Java has some really awesome features. Python also has some awesome features. Java is likely to perform better than Python as well, right? C is likely to perform better than both of them. Um, how many of you are taking data structure right now? Okay, so it's not a lot, which is good. Now I can assume no one knows the structure. I can then safely assume all my assignment would be not be based on that. Um, how about the algorithm class? Awesome. Good. Perfect. If you took algorithm already, this class might be a little bit too easy for you. But you have to take it anyway, so please go through them. And algorithm is fun. And you might have noticed I stopped before I said fun. Yeah, I think that's probably the best way to put it, like fun, right? It's one of those class where assignment sounds crazy hard until you see the solution, like until you got to the solution. Oh, okay, it's so awesome. Like, you can think of it this way. So that's how I find fun. Like basically, you would bang your head on a wall so many times until you got the solution. And when you got to the solution, you feel so proud of yourself. Like, hey, I can now actually derive whatever I'm being asked to, right, by myself. Um, and you guys, yeah. So you play Dark Souls. That's probably the right analogy to to algorithm, right? So I do play games. Yes, I still play games sometimes these days, and I play a lot of games. Don't look at my Dota 2 profile and how many hours I clock in. It was embarrassingly high number. Back in the day, I do play Dota 2 a lot. I still play a bit right now. I'm those age range where when I grew up, Dota 2 was popular, and Dota before Dota 2 was popular before that. Um, I did play Dota like quite a few rounds of Dota 2 with Ajahn Concern actually when we were at CMU. And it was really good. I was bad. And yeah, I do play games. The reason why I got into how do I design a computer, actually, so this is my personal story, right? I'm not a pro, definitely not. I'm bad. Um, I like playing games, right? And I'm definitely really bad at graphic design and everything. So one of the things that I'm like fascinating me is how does computer actually play games, right? So I got more and more into how like about computer design, right? And I had a chance to went to do an internship during my first year PhD at AMD. And if you might have noticed, AMD actually produced the GPU, right? How many people use the AMD GPU for their computer? Yeah. So at that point, it actually kind of fascinated me to learn how the GPU work, right? And then I had a paper with basically it was a research paper on how do you manage the memory when you have this on-chip GPU. Back in 2012, that was a new cool thing, right? You can now your we can put enough transistor on the CPU to the point that you can actually now put the GPU on the chip. It's a small GPU, right? But when you do that, there's so much effects on performance when you run things like YouTube rendering or play basic games, right? So we were looking into how do we still ensure that the CPU will run fine. So we have a patent as well as a paper from that. And from that point on, I was like, okay, yeah, cool. So I look more and more into how GPU works, which is one of the main component behind my own entertainment complex, right? If you're waiting for the Intel GPU, I'm also fascinated by their design. I'm looking forward to how they would scale and then see if they can compete with the NVIDIA and the AMD ones. Actually, Intel is actually building their own GPU as well. Um, so from that point on, my thesis basically on how to build a GPU, right? I did work with multiple companies that look into both the system side of the GPU as well as the hardware side. So that yeah, I do play games. Coming back to the content of our class, when you ask like what games do I play, and the algorithm, where did I get sidetracked so much? oh, we start from algorithm, and I compare that to Dark. You compare that to Dark Soul, right? And that's a good comparison. In any case, coming back to the content of our class, I think it's like my third time going sidetrack. I'm not sure what happened with me today. But I do this a lot anyway. So if I refer to anything that you do not know in this class, please tell me. And based on the response from the chat, which I love, right, is just let me know. I'm not a crazy guy that say, hey, don't use the chat. I think the chat is a perfect place to elevate your online education, right? That's how you can talk to your friends. That's how you can talk to me. And if you don't want to ask like the question in front of the class, you can send me a private message on the chat too. I read all the things from the chat. So I'm gonna respond to the question. All right. So let me first begin. Why should you care about systems, right? Because this is a class about how does the low level programming works, how does C work, and the class name itself is system skill, right? So most computer science and computer engineering courses emphasize on abstraction, right? You might have heard this word a few times in Python class, right? You can abstract a lot of things to simplify, right? To simplify whatever is underneath the detail behind the abstraction. But this class is doing kind of like a reverse of that. We'll start from the inside and go outside, right? We will introduce you to what's going on in your computer and what happens when you run a program, right? When you have a Python program and you want to run it, magic happens. Somehow it run your program and it compute and assume there's no bug, it works, right? How does it happen? The abstraction that we have has limits, especially when you have bugs or you want to understand the underlying implementation of certain things. You need to crack things open and understand what's going on, what's the code, how does it work, right? And the stress is on this third bullet point here. If you know about how computer works, you can definitely be a better programmer. Why? There are things we can teach in this class that allow you to understand, hey, that's how bug some element of the bug you're gonna see is generated. And that's how new language get rid of that bug for you without you having to worry about that. That's the beauty of, for example, Python or Java versus C, right? Um, and how to write a fast and safe code, right? I think all programmers should strive for that. At the end of the day, you want your program to obviously deliver all the features that you promise, but you want them to be fast and safe as well whenever you run the program, right? And this also prepare you for other advanced classes like operating system, computer architecture, distributed system, back-end technology, parallel programming, and there was a class called parallel programming and programming language. It was called OPL, but it's the same class, right? We changed the name. These require some understanding of how the computer works so they can exploit them. You buy the computer, so you want to squeeze out the performance as much as possible, right? What else? So you might want to care about system if you want to say design and improve upon the current OS, right? Sorry about the typo, it should be capital S. Like if you want to scale your system or infrastructure, right? You have a startup. Let's say you have a startup company. You're starting to get rich. Income are coming in. Work coming in, and then somehow you need to now scale your back end infrastructure so that it can support 10 million users instead of 1 million users. Yay, right? It can be hard. It can be hard to support 10 million users at the same time. It can be even harder to support 100 million users at the same time. It's hard to design the system for Facebook because there's so many users across the globe, right? Facebook actually hires so many system engineers who would be basically take care of their servers and their system to make sure everything run, right? If you want to build chips or design a cool new hardware, basically now go the rabbit hole that I walked through, right? Come up with a new hardware design, dream about how your computer should change for future workloads. If you want to work with supercomputer, there's so many optimization on the program itself and also on the algorithm that would allow you to run a program really, really, really fast, right? Ajahn Kanat actually is one of the expert on the area we call parallel algorithm. There's not a lot of people in the world actually to be an expert on that area, and he's really, really, really good at making your program run really fast. You want to invent new cool libraries or APIs for other people to use. If you want to work in the cloud, like basically manage the cloud, you go and get employed at Amazon and be an engineer behind Amazon Web Services, or you want to do like handling a large database. You want to work with IoT. Surprise! IoT is actually not about embedded system. This is what so many people in Thailand got wrong. IoT, Internet of Things. You have so many devices connected between each other. How are you going to manage all those devices in the setting so that the system doesn't fail, so that it's reliable, so that it can still compute whatever you want to do? And then there's so many, many more things that can be the benefit of knowing how the computer works. So now let's crack this black box, right, that we call a computer, and let's do it one step at a time. We're not going to do everything in this class. There'll be the next class called PCSA, Principles of Computer System and Architecture, the class that required you to take this class first. We will dive deeper into the computer system and architecture, which follow the material from this class. And now we'll cover basically three materials in this class, right? There'll be three modules. We'll start with Linux environment and all the useful tools. We have the server set up for everyone here. Everyone has now an account. I just generated everyone's account this morning. During the in-class exercise, basically after probably we should be done about around 3 o'clock, assuming I don't go way too sidetracked. All right. But around 3 o'clock, we'll switch over to you doing the in-class exercise and connect to the server so that you can start to program on there. And once you finish the class, then you're going to understand what happened when you run a program. Like really, what are the steps that happen underneath when you start to run your program? What might have caused the bug or the severe slowdown that you see? And hopefully you can make your program run faster, right? And the first module on Linux, literally the first of the three lecture, you learn how to use Linux shell, basically how to operate Linux, and then end with regular expression and Git. Basically, you're gonna learn tools to allow you to be lazy, and so that you can use Linux for your own benefit, not banging your head through how do I use Linux, but now you can use it to become lazy. And I think that what all the developers should strive for, right? Use all the tools from your arsenals so that you can be as lazy as possible, be time efficient, so they can move on and do many, many awesome things. Second module is on C, right? So basically, yeah, learn a new language, how to code in C, what's a pointer, how to manage data in C. We are not going to cover C++. If you took Java and Python before, C++ is basically object-oriented version of C. You might have to learn a new syntax, but the way it operates on a high level is the same. It's like object-oriented with C language and C syntax. Then we're going to learn computer systems. You learn how the computer store your program and your data and how the data is associated with the program. We will cover data representation, data manipulation. We will learn assembly, like basic ones, so that you can get familiarize yourselves with this alien looking language. But that's generally, I'm not going to ask you to program a lot. It's really, really basic ones. But this allows you to actually understand how the computer actually speak to you, human. How does all this voltage from the 5 volts that you put in, or the 12 volts that you put in, depending on what parts of the computer you're talking about, how does it transfer and become a program that runs? what happened when a program access the data, and how to make sure that your data access is really fast and also easier to program. All right, so the tentative schedule is this will be posted or updated on Canvas, but this changed a lot throughout the semester. Sometimes I go fast, sometimes I go slower, depending on your pace, right? Sometimes we have more questions on the Linux part, so I might use more than 3 lectures. I can use 4. If I if there's more question on the C part, I would expand that and make sure you all understand it. Typically, the class schedule is designed so that we have like 2 empty space at the end. That's the room for that I can expand additional topics that we want to discuss. Topic will likely follow what's on Canvas, but it's not tentative, right? So I'm gonna put that up. There'll be 2 quizzes throughout the class, one after we covered Linux and C, and one at the end after we start to talk more about what's the data representation, how does the memory work, what's the computer. The format of the quiz is still TBD, but it's likely to be a mix of the open-end question, uh, written question, and a programming exercise. Um, what I typically do every single semester, I'll have you guys vote on, do you want it to be 1 day? Do you want it to be 3 days but longer? Etc., etc., and what day should we start? So it's more relaxed with this format. One thing I find is a lot of people here will start to collaborate on the exam. Don't do that. That's illegal. Don't don't collaborate during the exam. Right? There'll be 24 lectures, 5 assignments. You might have noticed if you retake this class, like, hey, 5. So there'll be one more C assignment this semester so that I can prepare you all for the next class, the PCSA class. The last iteration of PCSA class, everyone suffered through the first 2 labs because I feel like you need to actually program more in C so get used to it. It's going to be programming based with 2 late tokens total, and you can use up to 1 per assignment, right? And late homework afterward will not be graded. And the breakdown is pretty simple. There are 2 quizzes, it's 20% each. The rest 5 assignments will be 10% each, where 90% of that, 45% in total, will be from your correctness, and the 5% is on test case. And it's fair game for me to use one of your test cases on your friends. So we, oh yeah, that's a great question. I use the word quiz, that means exam. I think MUIC has a policy where I can't use the word exam unless it's on the scheduled date by OAA, because it's online and I want to open up, like, do you have conflicts or do you want to have the exam on a different day? I use the word quiz so that I can pick my own day for the exam. I'm sorry about that. It's weird, I know. This allows you all to let me know, oh, I have so many conflicts here, and that would allow, yeah, sorry. Yes, basically that's what it is, right? Yeah, so those are the exams. And 5% participation. And for now, with this amount of things on the chat, this is awesome. So you should get that free 5%. All right. Uh yeah, I can use your test case on your friends. And if there's a really good test cases that fail all your friends' program, that's extra credit for the guy who made the tester. All right. Um this is just, yeah, I just tell you all to be evil. But yeah, I can use your yeah, this is fun. Uh, and the other 5% is in-class exercise. You need to submit all of these by the end of the class. It's okay to work in group on Discord for all of this. Um, well, I'm not gonna tell you your friends who you are. I mean, all right? Yeah. Oh, yeah. That, I mean, I have my own test case too. So So don't worry. And then we have a default tester as well, which typically would kind of kill your program anyway. So if you pass those tests, typically you get full credit. All right. And yeah, obviously I'm gonna tell your friends who you are or who is making that killer cases, right? Um, and policy on collaboration. I strongly believe in the power of collaboration. And actually, to be honest, I feel like Thailand as a country should benefit more from brainstorming and like pulling together ideas because people can contribute, right? So I encourage you to discuss material. I encourage you to discuss how to debug a program, or hey, I have this killer test case that I spent so much time thinking about. You can actually try. So sharing the test cases in groups, I would allow that, but don't copy solutions. All right. I also encourage you to come up with creative way to test your program together as a group. You must write your own code. If I suspect that you copy from your friends, I can ask you to explain your code in a live session, and I did that before. It was ugly, so don't let me go there. It can be tough to explain your code in a live session on the spot. No collaboration on the quiz and the final. Basically, if it's exam and you collaborate, you'll be heavily penalized. This is the policy: no code sharing, no copying, retyping, looking at your friend's code on the screen or file, right? Or tell your friend to write it line by line. You can you cannot copy code from the previous course or from the internet, like direct copy from Stack Overflow. That's not okay. These are okay. These discuss a high level design, discuss how to use certain tools, work together to come up with a creative way to kill your program, right? And here's my policy, the default one. I can tell you most of the time I give you 0, but this is a default way more severe penalty. You get a negative grade. You can be inspired by Stack Overflow. I mean, obviously, when I was undergrad, I searched certain explanation quite a bit. Like, hey, what's this binary search tree? How does it actually work? And then I implement it after I understand how it works. The problem with copying from Stack Overflow is most of the time you copy and you don't know what's going on the code. And that's bad because at the end of the day, you have to implement on a job. You can use Stack Overflow to find how to do certain things, right? But you need to understand what the code is doing. Because if the code looks similar, say from Stack Overflow, I'm gonna ask you on the spot how it works. All right. And as I said, that can be tough if you don't know how it works. Okay, fair game, fair game. I mean, many of the things we ask you to do, I'm sure there are solutions on the internet. Because there's a lot of these are kind of like standard data structure or things that we are asking you to do. But at the end of the day, if you are here to learn, you pay tuition so that you can learn and you can program so that when you go and find jobs, you can be an awesome programmer and get hired and get paid. And if you go abroad to the United States, you can maybe get paid quite a lot actually. Um, so yeah, that's our policy so that you can get good. Conflict. If you have exam that are online during a live session that you have a conflict with, let me know because to be honest, there were, for example, one semester where all the professor scheduled their exam on the same day for the online, like 1 day exam. So, and the student told me that like, we can move it to another day, otherwise the guy would die, right? So if there's conflict, let me know. Here's my expectation. There'll be a lot of new material, so ask questions when you're lost. Email me the question when you're lost if you're not sure how to frame the question during the lecture. And you work hard. You're learning a new language. You're learning a new concept. Assignment will take time. So read the assignment early. then think about how many hours you need for the assignment. Multiply that by 3. Make sure you have allocated that many hours for the exam. All right. The reason why I said multiply 3 to your own adjustment, because sometimes there's a hidden surprise that, hey, this part is harder than I thought when you implement the code for real. All right. Quiz can unlikely be hard. Stop me if I'm going too fast, especially after like basically what I would do is around 3 o'clock, I would do a quick like 5 to 10 minutes break. What I did usually is I'll go get coffee, and afterward I talk a lot faster than right now. Right? So if I'm talking too fast, let me know. But the goal is let's have fun. Um, and we have a server. You have access to the syskill server if you go to in class exercise 1 on the on our class website. Uh, we will use the server for this class. You can use it for the PCSA class as well. The explanation on how you get there is on the in-class exercise 1. Most of the time, just follow the snippet of the command we give you. If you use Mac OS and if you use Windows, they are both different programs that you can use to get to the server. So let's begin. Let's begin. And I'll begin by asking, what's a computer? What's your I don't even want to use the word definition, but what's your understanding of if I just randomly yell computer, what would you think about what would be the image on your brain? Can someone tell me that? Games. Okay, awesome. That's kind of like mine. Yeah, if I'm a first year undergrad, that's basically what I'll be thinking about. RTX 3090, that's a part of the computer. It doesn't have the operating system of its own, so you can't just run on RTX 3090 alone. You need a CPU. Some cool machine, Bitcoin mining. Okay, awesome. Those big Google server, right? So auto heating machine, that's a great answer. So these are also computer, right? Wait, you're talking about your own computer that's really hot? And you're not talking about those like embedded device, right? Basically, it's just your laptop is really okay. Yeah. I guess auto heater. I mean, your personal heater also works as well. Um, yeah, it's a machine that. What does the computer takes for the input? So let's use a microwave. Microwave has a computer inside. So what's my input for the microwave? You just hit the command, right? The power at a time, right? How much time do you want, and then beep, and then somehow it's cook whatever is on in the microwave. So what's the output? It's basically is the microwave signal, right? That heat up your food, right? Food that usually tastes good. Really, really good representation of a microwave food. Yeah, it does have a sound and an output. When you hit the button, it produces some sound. It also generates this light, right? It turn on the light. It turn on the generator for the microwave so that it heats up your food. And then when it's done, it generates another sound. Ding, it's done. And turn off the light, right? So a computer basically takes input, right? And it processes your input into the output. So can I do the same with calculator? Can I do the same thing with a calculator? So then what make a difference between your calculator and your computer, your laptop? And obviously your calculator cannot heat up your food. Your laptop might. Um, some brand of phone might be able to heat up your food, but it is programmable, right? You can write a program and you can run different program on your computer. And also a fancy calculator like TI-89, you can run a program on there as well, right? So basically you can ask the computer to do different tasks, a diverse set of things based on the program, right? So here's computer 101, right? So, I mean, the hardware won't let it do what? Is this still the joke about heating things up? Oh, doing what it's not supposed to. But because it's pretty powerful, right? In terms of what you can program, it is cover a diverse range of tasks. But yeah, depending on the hardware. I guess depending on the CPU, we could probably disable the logic that would cut off the CPU when the heats go up too high, and you can cook food that way too. But I definitely not recommending that, right? Um, Microwave, the processor going there can probably calculate math. Why? Depending on what you put in as an input, there's actually some math calculation needed, right? How much of the output do you want to produce? Should I turn up and down the heat and the output, right? Depending on the setting. It actually can perform some maths. But here's the computer 101. You have the processor. Input device. Can someone tell me what's the basic input devices on your laptop? Keyboard. Awesome. Right? Keyboard and mouse. Uh, what about the output? The monitor, right? Or the speaker, printer, screen. Yes, awesome. Anyone heard about DRAM, the main memory? The memory. So what's unique about the memory? So how many of you, when you have to solve a complex math question, you need a scratch pad to scribble things and do the intermediate steps? So your CPU is like a complex, uh, complicated calculator to some extent, right? That do a lot of math operation. And yes, exactly. It's where you store the temporary data. It's kind of like that scratch pad when you are solving some complex equation. You do it line by line by line until you arrive at a solution, right? In the meantime, you would put the intermediate data in the main memory. That's what the computer use this memory for. There's also many other things like handling all the processes, all the program you're running, right? It also is a place where your input and output device can interface as well. So you can store the data on the memory, right? For example, if you take a picture on your phone, that's is that input or output? You're taking a picture on your phone. It's an input, right? The first thing that happened when you have the sensor reading every color information and the light information coming from your camera, it directly write to the memory. It write the data to the memory so that your processor can take the data and process some of the whatever picture you're taking, send it to the monitor, right? So that's how you get interface between the input and output for your computer as well. And you might also heard about the word operating systems. Like anyone use this thing? What's this? What's this graphic user interface? I am pretty sure that's not Mac OS. That's Windows 10, right? And this is Mac OS, right? And these are Linux, right? How about this? Have anyone seen this? Yeah. So if you use Windows, if you open up the command prompt, right, it would look something like this. If it's on Linux, it's called the terminal. If it's on Mac OS, also is based on Unix as well, so it's called terminal as well, right? That's why you can put in the command in a text base. More of the I just put all the command through the keyboard. Everything be shown as a text-based thing. Conceptually, so these are sample of some of the features of the OS, right? But conceptually, what is an operating system? You have the user that run the program. So user is you, and you want to run a program. And you have the computer. This is your hardware, right? This is a computer. The user, you cannot just say, hey, computer, run this, right? You can't just directly go and use the hardware. What you need to do is you need two things. First, you need the application program. Google Chrome, YouTube, Adobe PDF, Steam client so they can play games. Those are application programs. The second thing, if you want to run any program, Windows and Linux, these are operating system. And as the name suggests, operating system is a system that's used to operate the hardware. It allows you to drive the hardware and run whatever program you're running. So you can see the arrow sign. Arrow sign is basically interaction between each of these components. The hardware can talk to the operating system. Operating system can send command to the hardware. Application program would interface with the OS, right? You run your program in Windows and Linux, and then Linux will take the command and forward to the hardware so it runs the correct thing. User, you can also interface the OS. You browse things, go and open different file, right? Those how the user can interface with the OS. So that's basically the concept, like conceptually how we should visualize the things that OS is supposed to do. Then there's this thing called UNIX. UNIX is a multi-user, multitasking OS. As the name suggests, multi-users mean many people can use UNIX at once, at the same time. Multitasking means that if I run multiple programs at the same time, UNIX can handle that. It has a different version like Solaris, AX, Linux, and Africa. You might have seen one family names here. Linux basically kind of take over. And typically these are used in things like scientific technical application, is used in cloud infrastructure, like the backbone behind things like um, company like Google and Amazon was developed using the Unix-based OS with a lot of modification, right? So it's a lot of modification afterward. It's used in many IoT devices that are more advanced, and it's not just a microcontroller, things like actually having a computer like Raspberry Pi or NVIDIA Jetson, right? Also, you can use it in PC and workstation. And Linux is available in many distributions. So there's a difference between each distribution. It takes the core code from Linux. Each distribution modifies certain elements of the core kernel code so that it has a different flavor. Like CentOS, Ubuntu. Ubuntu, for example, would have a newer package API, cool new thing implemented, available for the user. It's actually pretty end user friendly. Fedora is more stable. If you use Fedora before, it can be annoying because some packages are not supported because they're still testing and making sure those are stable, right? There's also Debian and many other distribution of Linux. And as we showed earlier, there's this thing called terminal, right? A terminal, sometimes the full name is called terminal emulator. Anyone heard about the word emulator before? This word. for a totally different purpose. Anyone heard about this word before? What do you use it for? Yeah, it's like PS2 emulator, right? So if you're not familiar with the word emulator, one of the things that a lot of people use emulator for is, what does the word emulate mean in English? What does the word emulate mean? It's kind of like copying something, right? Imitating something. It's not it's basically imitating. For example, if I say PlayStation 2 emulator, it's a program written to emulate what PlayStation 2 is doing, right? And the reason yeah, that's a really good definition, by the way. But emulator basically emulates certain thing. PS2 emulator copy and imitate what PlayStation 2 can do. So you can run PlayStation 2 game on your computer, even though they use a totally different language. Even though they use a different language. Computer use x86 assembly. PlayStation 2 use MIPS assembly. Um, they can't talk to each other. So you need to emulate the MIPS assembly on your computer, which is x86. Terminal application or terminal emulator, basically kind of the definition is it emulate the video terminal. You're supposed to be the monitor, right, of the server onto other display architecture, your own monitor. All right. So let me go back to, here's your computer. You have keyboard input and the display, your monitor, right? What terminal is doing is, well, that's your, let's say this is the server, right? This is a server you go and use. Where is the server? Can someone tell me where is the server right now? Anyone want to take a guess where is that server that we are gonna connect to? Yeah, somewhere at the university building, right? No, not at my house. It's actually at MUIC. Um, can you physically go there and use it? Yes. You can connect the keyboard and the monitor, and you can use the server. Can you connect to the server from somewhere else? Yes. Right? That's what the terminal is for. So that's your own computer at the bottom after this dashed line. The terminal forward your own keyboard input, make it emulate and act as if these are the server keyboard input, and then put in a display to your computer as if these are the display from the server. You can also use the terminal on your computer, right? So in this case, it's the same machine. Is it more clear now? Basically, the emulator would forward the input and the display to your own computer so that you can connect it remotely. You can stay home and work remotely. For example, I have a setup on my lab, and I actually haven't gone into my lab for 1.5 years now because of COVID, but I can still work and connect to my machine. All right. So this is basically the beauty of having a terminal. Here is you can use the terminal called PuTTY for Windows, or you can use Windows Subsystem for Linux, which is much more convenient. That's kind of like I would show you how to do both of them later in a few minutes. Um, if you use Mac OS, here's one of the sample of the terminal in Mac OS. And before we actually go for the in-class exercise, there are a few more slides that I need to tell you about how your OS works. Everyone heard about the word program, right? How many people heard about the word process? Anyone heard about the word process? So What do you pair it with? How many people open a task manager when your computer is starting to crash and try to figure out anything like not responding so that you can close it? Yeah, end task. Right, the end task thing. Program is it's an application that you are going to run, right? That you are going to run. It's the program that it is installed on your machine. Process, right? Program is basically like a binary data that you can run. Process is the instance of that program running. So whatever is running on your computer is called a process. Whatever is being run on your computer, whatever program is running on your computer is called a process. For example, it's like 18 the 17 tabs on your Chrome, right? That Chrome application is a process. That can be another process generated by Chrome that can handle different tasks, like rendering some certain graphic or video, right? Then another program that we'll use a lot is called Shell. It's called Shell. Basically, what it does, it takes your command, send the command to the OS. That's it. It has the ability to understand your command, and it has the ability to send that command to the system so that it run that command. So that's what Shell is doing. That particular interface between you as a user, it talks to the OS for you, right? This allows you to control the OS directly. This is another cartoon picture showing how shell actually work, right? If you look at OS textbook, you might have seen this word kernel before. Kernel is basically the operating system program that manage your computer, right? It manage whatever is running from the application. It manage all the utility that you have for the computer. And then there's shell that takes your input and send the output back to you, right? So we can use a combination of both shell and terminal. So on your own machine, you can have your own machine. This is your laptop. Basically, this is your laptop. There'll be a shell program that send command to the OS. That's a terminal. And that's you. You send the command to the terminal. The terminal then forward. Basically, shell would interface with the terminal, take the command, talk to the OS. If you have a server, so let's say this is a server, right? There's a shell program on the server, and here's your computer. Where is the terminal? Where is the terminal? Is it on your computer or is it on the server? Actually, it's not in the cloud. It's not in the server. It's actually on your computer, right? Because that's where you type. You type the keyboard there. That's because you emulate the display from the server. So the terminal emulate whatever is on a server. But in this case, shell is a program on the server because you have to send the command directly to the computer. That's where the computer is, right? The server. So in this case, you send the command through terminal, through shell of the server, submit the command to the host OS, right? And basically, this is your setup for in-class exercise 1. You're gonna connect to the syskill server. Please follow our in-class 1 worksheet. Please follow our in-class 1 worksheet. We're gonna swap to Discord, and I'm gonna stop the presentation right now. Actually, I'm starting the recording.